Hey everyone, we are going to be reviewing for Unit 7. So this is all of our trigonometry that we have learned and getting ready for our test. So this is going to be really similar to our test, similar length, similar problems. So let's get started. Our first problem is finding the area of a triangle. And we remember, obviously we know that the area of a triangle is 1/2 base times height. But for trigonometry, we're going to use this angle that's included between these two sides. So the area of a triangle, remember, is 1/2, and then we're going to use the two side lengths that make this angle. So 3 times 6, and then we're going to multiply that by sine of this angle, so sine 108. Remember when you're using your calculator in a moment that we are in degrees. This is sine 108 degrees. Okay, so we can go actually straight into our calculator now. If you don't have this calculator, it should be pretty similar functions, might look a little different, but let's go ahead and calculate this into my calculator. So 1/2, I always use 0.5, and then we are going to multiply that by 3 times 6, and then the last one, sine 108. And then don't forget, this has two parentheses, so the one around sine and the one around the degree, so I'm going to double parentheses that. And you should get 8.5595 with the rest of the numbers after. We are going to round this to the nearest tenth because that's what it asks us for. So I'm going to first write that this is 8.55. I'm going to write out the answer for a little bit. And then if we round that, that's going to be 8.6. Let's see what our units are. Centimeters. And this is area, so it's squared. All right, next one, we are finding the measure of an angle. This is when we ask ourselves if we're going to be using law of sines or law of cosines. Now, law of sines is what we're going to use for this problem, and that's because we have an angle, side, side. Now that should also tell you something else. When we have angle, side, side, I'm going to write it the other way so it's appropriate. This tells us that this problem is going to be a pain in our angle, side, side because this is our ambiguous case. Ambiguous case. So let's not forget that when we're doing our work. All right, let's get this started. So the law of sines tells us that the ratio of a side length and sine of the angle opposite equals sine of an angle over the side opposite. So let's set up that proportion. Okay, so sine of angle B over the side length opposite is going to be equal to sine of angle A over the side length opposite. All right, now let's put the rest of our values in so we can solve this proportion. So this is sine 100 over 9 equals sine A over 4. And we have to isolate A. Now I have sine of A, so that means at the end of this we are going to be using sine inverse, and we will definitely need our calculator for that. So if I solve for A here, well, I'm going to first cross multiply. And I'm going to get 9 sine A equals, and then if I multiply these, 4 sine 100. I need to divide both sides by 9. And then I need to take sine inverse of this entire value, and that will equal A. So sine inverse of this entire value is going to equal angle A. All right, so let's try that out in our calculators. So we're going to do sine inverse, so I have to do shift sine, see how I have the -1 power here. And then in here, I'm going to do 4, let's see, you know what? Just to make sure we have the correct value, I'm going to calculate this first, then take sine inverse of it. So I'm going to do 4 times sine 100. I'm going to divide that by 9, and then I'm going to do sine inverse of that number. Okay, so we should be getting that the angle A is about 26 degrees. And since this is an ambiguous case, that means there is a possibility of a second answer. And we find that by doing 180 minus this angle. So we need to find the angle supplementary to this. So if we do 180 minus 26, that's going to give me 154 degrees. Okay, so I need to check and make sure that these angles make sense, that they both work. So I'm going to do that work right up here. I'm doing a different color just so we kind of separate this work. And I need to know that with the angle that's already present plus the angle that I found as an answer, that there's still room for a third angle. So let's try this one first. If I do 100 plus 26, is that less than 180? It is, so that one works. And then let's do 100, and then we'll add the other possible answer, and we're going to ask ourselves, is that less 180? It is not. So even though it's an ambiguous case, the second answer we found was not a solution. But when you're working on these problems, you do have to show that work so that your instructor, your teacher, your professor knows that you know this is an ambiguous case. Okay, so now that we have angle A, we can finally answer the question, which is what is angle C? So if I know two angles of a triangle, all you have to do is subtract them from 180 to find the third angle. Okay, so last bit of work over here, we're going to do 180 minus, my two other angles are 126, and I should find that that last angle is 54 degrees. So angle C is 54. All right, next problem, and now we're going to have to use the law of cosines because we have been given side, side, side. So when we're given that information, we use law of cosines. Okay, so for this problem, I'm going to remind us our formula or our law. And since I'm looking for the measure of angle C right here, then I'm going to call this little c, this is little a, and this is little b for the side lengths. So little c squared equals a squared plus b squared minus, and then for my classes, I always put parentheses right here because we always forget our algebra rules. So put those parentheses there, and then we're going to write 2 times a times b cosine and then big C, because that's the angle. All right, let's put those values in, and let me separate my work a little from the previous problem. So little c is 8, so I've got 8 squared equals 100 squared plus 9 squared, and then in here I'm going to do 2 times 10 times 9 cosine C. I don't know what C is. And then this is where we really need to be careful with our algebra. I'm going to square each of these numbers, add these two, make sure to keep these separate. These are one whole number right here in the parentheses. So I've got 64 equals, this should have said 10 squared, not 100 squared. So now it's 100 plus 81 minus, and then in the parentheses I have 180 cosine C. And remember, the whole point of all these equations is to solve for the variable you want. I want C, so I need to isolate this C. So I'm going to add these numbers and subtract them from 64. So on the left side I have negative 117 equals negative 180 cosine C. I'm going to divide now each side by negative 180 because this is a multiplication problem right here. So I'm going to divide by negative 180. So if you do that math right here in your calculator, you should get about 0.65 on the left, cosine C on the right. And then again, if I have cosine of what I'm trying to solve for, I need to use cosine inverse. So cosine inverse of this value is going to give me the angle. And so when I do this in my calculator, I'll show you guys that right now. So I'm going to do cosine inverse 0.65, and you should get about 49 degrees, and we want to the nearest tenth. So this is going to be 49.5 degrees, and that's your answer. And the last problem on this page uses the same exact triangle, but now we're finding the area. We have enough information to find the area, so let me label, this was 49.5 degrees. So remember, for area, we need an angle measure and the two sides that create that angle. And we do have that. That's this information right here. Okay? So your area is going to be 1/2 your two side lengths, 9 times 10, and then sine of the angle included. All right, and then again, if you plug this all into your calculator, you should get that your area is about 34.2 inches squared, and I just rounded to the 10th. Okay, moving on. We're going to do some quick conversions. We are going to convert from degrees to radians and then radians to degrees. Don't forget to do this. You either multiply by pi over 180 or 180 over pi. If you can't remember which one, just kind of think about what you want your answer to be. So if I want radians, that means there's going to be pi in my answer, right? So I want pi to be in the numerator because that way it won't cancel with anything. So I'm going to multiply these ones by pi over 180 times pi over 180. And then if I want my answer to be degrees, I don't want pi. So I want this pi to cancel with the 1 in the denominator. So these ones multiply by 180 over pi. Just like that. All right, so after that, it's just algebra and using what you know about simplifying fractions. All right, so for this one, when I multiply, I've got 70 pi over 180, and that's going to give me 7 pi over 18. I just cancel the zeros. 7 pi over 18. The next one, again, if I multiply negative 945 pi over 180, my final answer is going to be negative 21 pi over 4. Again, radian answers have the pi in the answer. Next ones should not have pi because my answer is going to be in degrees. So again, pi's are going to cancel. I've got an 18 and a 180. This is going to become 1, and then I can simplify this to 10. So all I have left is 33 times 10 over 1. So that's just 330 degrees. Okay, and then next one, again, pi's are going to cancel. I've got a 9 here. This is going to become 20. So then the math I'm doing is negative 23 times 20. That's going to give me negative 460 degrees. Okay, so that's converting. Now we're going to use what we know about our inverse functions and our quadrants on our unit circle. Okay, so this tells me that tangent of some angle, I don't know what the angle is this value right here. So they've given me the tangent ratio. They also told me that the angle is between these two angles. Now let's take a look at our handy dandy little unit circle. And when I'm between 3 pi over 2 and 2 pi, that's my fourth quadrant, right? So fourth quadrant. And let's think about what's true in the fourth quadrant. Sine and cosine in the fourth quadrant. Well, cosine is going to be positive. That's my x value. So cosine is going to be positive. And sine, my y value, is going to be negative. So we'll keep that in mind when we calculate these. Okay, so again, if I want an angle and I know what the ratio is, all I have to use is my inverse function. So in my calculator, I'm going to find tangent inverse of this ratio. And it's like I'm working backwards. This is going to give me what the angle is. Okay, so in our calculator, we're going to do tangent inverse of negative 4.580. And so my calculator is telling me that the angle is negative 77.68, right? So if I round that just for writing purposes, I'm going to keep that in my calculator. This is about negative 77.7 degrees. Then if I know what the angle is, all I have to do is calculate cosine of that angle and sine of that angle. All right, so first one we'll do cosine. So, oops, I deleted the number. Negative tangent negative 4.580. Okay, so we're going to find cosine of this angle. So cosine is going to be about 0.21. And then we'll find sine the same way. So again, calculating, getting that angle, and then finding sine now. Sine of that angle. So sine is about negative 0.98. So I have my ratios here, and I'm just going to double check. Cosine was positive, good, and sine was negative. And we're done. That's it. All right, the next ones we're not going to use our calculator, so we're going to use what we know about our unit circle. So we have right here our tangent, cosine, and sine functions, and we're going to think about what these look like on our unit circle. So the first one, tangent 480. So 480, well, that's more than a full rotation, so I'm going to find out what the coterminal angle is to that. So I'm going to find if I did a full rotation, how much more would I have to move to get to 480? So I'm going to do 480 minus 360. It's going to give me 120. So on a graph, use my different color. On a graph, so if I did a full rotation plus 120, my angle is going to be right here. All right? So that's 120 degrees. So if I find tangent of 120, that's the same thing as tangent 480. So tangent 120, well, I know what sine and cosine are. So remember, tangent is sine over cosine. So tangent of 120, well, sine of 120 is root 3 over 2, and cosine is negative 1/2. Remember, dividing by a fraction is really multiplying by the reciprocal. So this is really the same as root 3 over 2 times negative 2 over 1. My 2's cancel, and I've got negative root 3. So tangent of 480, which is the same as tangent 120, is negative root 3. And you're done. All right, our room is running out. So the next one we're going to do is cosine negative pi over 2. So again, let's see what that looks like on a graph. Well, if I move in the negative direction, that's clockwise. So starting at 0, negative pi over 2 is right here. So this angle right here. So I need cosine. Well, again, looking on my unit circle, cosine of this angle right here is 0. So cosine negative pi over 2 is also 0. All right, and then last one, let me move over my paper. Split this up a little. We have negative 16 pi over 3. Now this is much more than 1 or 2 rotations. One full rotation is 6 pi over 3, or 2 pi. So negative 16 pi over 3 is 2 full rotations plus another 4 pi over 3. So again, thinking about like on a graph, we would go 1, 2, and then another 4 pi over 3. So it would be right here. We'll ignore the negative for a moment. So what I'm really trying to find is sine 4 pi over 3. Sine 4 pi over 3. Well, again, that's a value we have on our unit circle. So sine is going to be negative root 3 over 2. And then all I have to do is change the negative to positive or keep it. So since this was positive 4 pi over 3, I just need to know which quadrant negative 4 pi over 3 is. So draw a quick little graph. If I were to start at 0 and move in the negative direction, negative 4 pi over 3 is going to be in this quadrant where sine is positive. Okay, so sine of negative 4 pi over 3 is positive root 3 over 2. All right, let's move on to some graphing. So our first graph, all we have changed, or as a transformation, is the asymptote. So we have multiplied by 4. This is going to change our graph vertically. So what I'm going to do is graph cosine, but it's going to have an amplitude of 4 instead of 1. Okay, so remember cosine always starts at 1, but we have stretched by 4, so it's now going to start at 4. And then remember cosine comes down to the x-axis at pi over 2. Then it goes to its minimum at pi, but instead of -1, now it's -4. It's going to come back to the x-axis at 3 pi over 2, and then back up to 4 for 2 pi. So let me draw in this curve what I have so far. Oops, missed the point a little bit. And then I'm going to draw in one more period. So it's going to come back down. I'll go a little faster this time. Down to my minimum, back up, and then another full period. So connecting these and completing my curve. And remember, when you are taking a test or a quiz, at least for me, I always prefer 2 full periods if you can. And that's what I've done here. So this has 2 full periods. So remember, the amplitude has changed to 4, and the period was still 2 pi. So that's how long a full rotation is. All right, the next one we have is sine. And again, we've only changed our amplitude here. We have a -1/2 for our a value. So that means that our graph is going to flip over the x-axis, and the amplitude is now 1/2 of what it normally is. Okay, so sine always starts at 0, and then instead of going up to 1, we're going to go down to 1/2. Back up at pi, and then instead of going down, it's going to go up 1/2, and then back down. Okay, so you'll see this is like an upside down sine curve, and then I'm going to move in the negative direction, so we're going to go up 1/2, down to pi, down 1/2, and back to -2 pi. And completing this right here. So again, I tried to fit in 2 full periods. So this amplitude, or a value, was -1/2, and the period was still just 2 pi. All right, and then last one that we did not get to do together in class, but I'm going to show you how, is writing an equation for a certain graph. Okay, so what we're going to do here is kind of take apart everything that's going on in this graph. The first thing that's really easy is to find the amplitude. So I've got my midline right here, so that's where our graph starts, and our max and mins go up or down 2. So I know my amplitude is going to be 2. Then let's take a look at our period. So we're going to find out, where do we have a full rotation or a full sine or cosine curve? Now I know this is sine because it starts at 0 right here. Okay, so we know this is sine. And a full period, so I'm going to kind of highlight where that is, stops right here. Now careful. This is not 2 pi, it's just 2. So we know that the period is 2, not 2 pi. But what we don't know is that b value. We have to find the b value that goes into our equation. So if you'll remember from when we wrote our equations with transformations, I found my new period by taking the old one, 2 pi, and dividing by b. Now I know what my new period is. It's 2. So let me write that in. Then we're just solving for b. So I'm going to multiply both sides by b. So I've got 2b equals 2 pi. And then we're going to divide by 2. So b is pi. So that's the number that's going to go into our equation. So b equals pi. All right. So now we're ready to write our equation. So we're going to say, go back to my purple. Y equals, remember my amplitude's now 2, that's my a value. We know this is a sine function. And then our b value is pi. So that's our equation. Now there are a ton of different possible answers. You actually could say that this is a cosine function, but just with a horizontal shift. Okay, but this I think is the simplest answer. All right, let's move on to our last graphs, Now, as I did in my lessons, I have already graphed the parent function. Now, it's going to look a little funny because our x-axis has been kind of stretched out, and same thing with our y. So this looks a little funny for sine, but this is just our normal parent function of sine. I'm going to go in now and graph our transformation. Okay, so let's take a look at what's happening here. I've got my a value, it's 1/2. So a equals 1/2, that's my new amplitude. I've got a b value of 3. So if I want to know my period, I'm going to do 2 pi divided by 3. So that's my new period. All this means for you guys for graphing is you're just dividing all the x values by 3. Okay, so this just means divide your x by 3. And then the last thing I see is a vertical shift down 1.5. Okay, so let's get started on this graph. The first thing I want to do is kind of shift everything down. So normally I work off the x-axis, but I'm going to shift that down to negative 1.5. So I'm actually going to kind of dot that in so I can see where I'm working off of now. Okay, and then again, sine starts at 0, but we've moved down, so that's now at this point, we're treating this as our new x-axis. And then let's see what happens for moving forward. So I am going to have a full period in 2 pi over 3. So this point right here is going to be where my graph comes back down and where my period ends. So I know I've got to do a full sine curve in this amount. I also know when I go up, I'm going to go up 1/2, not 1. Okay, so from negative 1.5 to 1, negative 1, that's 1/2. So that means all my maximums are going to be up here. Okay. And then again, I need a full sine curve. So I'm going to come up 1/2, down 1/2, just going to eyeball it, and back up. So remember, always think about what your full sine curve looks like. We go up back to the x-axis, down back to the x-axis, and that's a full sine curve. We'll do one more. So we're going to go up 1/2, back down to the x-axis, down 1/2, and back up. So those are 2 full periods. Okay, last graph, we have a tangent graph, and I have my parent graph on here, just so that we can see kind of how this shifts and how this stretches. Okay, so what I have here, let me change my color one last time, is an a value of 2, so my amplitude is 2. I have shifted to the left pi, and I have shifted up 3. Okay, so that's all that's going on here. What we're going to do here is we're going to shift first, kind of find our new place where our tangent graphs will occur, and then we just have to stretch them by 2. I do want to show you guys something real quick, and that's my horizontal shift. So what I'm going to do is kind of show you on this patty paper how when I shift pi, my asymptotes don't actually change. So let me show you why. So I'm going to line this up right where my asymptotes are. Okay, hopefully you can see that. And I'm going to shift pi. Now on this specific graph, pi is 2 tick marks. So this distance right here, this is pi. So I'm going to shift over that amount, 1, 2, and you will see that these asymptotes still line up with the same original ones. So I'm going to keep those asymptotes there because even though I shifted to the left pi, they remain the same. So now I'm going to go in with my transformation color, and I'm just going to keep those because I know now that those are just the same asymptotes. Now my graph's definitely going to look different, but my asymptotes will still be in the same place. Okay, now we've got to shift up 3. So I'm going to take my original point at 0, and I shifted over pi, so now I'm here, and I'm going to up 3. 1, 2, 3. So this is where I'm going to start my tangent function now. Okay, so normally on my tangent function, I go over pi over 4 and up 1. but I have a stretch of 2. So I'm going to go over pi over 4 and up 2 now. Let's do that in the negative direction. To the left pi over 4 and down 2. Draw in your graph. So you'll see this is like a stretched version vertically of tangent. And then remember, our tangent functions just repeat themselves to the left and to the right. So I'm going to draw another one in this set of asymptotes. Over pi over 4 up 2, left pi over 4 down 2. And again, draw in your curve. It's just a stretched tangent. And that's all I'm going to draw. So I've got 2 full periods of this tangent. All right, thank you guys so much for watching this video. I wish you luck on your Unit 7 test or whatever you are watching this video for, and I will see you next time for my next video. Bye, you guys.